Okay, so this is the second method. I just found the area of the triangle, so it's 54. Area of the rectangle is length by breadth, or you might say width, same thing. My length is 10, width or breadth is 6. So this is the area I'm trying to find, this red part. We just outline it. This is the rectangle. So that's 6 by 10, 60. So to find the total distance would be the area of this rectangle plus the area of this triangle, which would give me 114. So it's 54 plus 60, 114. Don't forget to unit meters. Everybody good with this?
Yes, miss.
Okay, nice. So once you're comfortable with this, that's great. That's really great. Speed time graph, very similar to velocity time graph, just some things you need to note, right? So speed, y-axis, time, x-axis. That's okay. The gradient, we actually just say it's acceleration. So just like the displacement time and the speed, speed time, displacement time and distance time graph, I said that some people use the gradient for the both of them as velocity. So they just use it interchangeably. The speed, we actually say that the gradient is just acceleration, right? I know it's technically not, it's just not what you learned, right? But that's how it is. So if you see a speed time graph, the gradient is really just acceleration. Straight line, constant acceleration, curve, varying acceleration, horizontal line, constant speed, area, distance traveled. Question mark, hold on. Speed and velocity gradient is acceleration. Yes. Yes, it is. But I mean, like I was saying, that's technically not correct based on the definition that you know. Acceleration is the rate of change of velocity, not the rate of change of speed. But that's how it is. We take the gradient of the speed time graph to also be acceleration. Oh, but from the graph, that's how it is. Yes. A curve. So this is basically the same thing as velocity time graph, right? Curve shows varying acceleration, horizontal line, constant speed, area, distance traveled. But the difference, just like displacement time graph and distance time graph, speed time graphs kind of go below the x-axis. Speed is a scalar quantity, so I could only have positive values for my speed. Velocity will. Velocity is a vector quantity. I could have both a negative value and a positive value for my velocity. So it can go past the x-axis. Let me just show you what that looks like. Remember, we'll never have negative t values. Can't have a negative time. That doesn't make sense. So velocity time, doesn't matter how crazy that graph looks. Just like just now, you notice how it went like this, came down all the way down like that. It went into negative values of v, negative velocities, values of my velocities. Can't do that with the speed time graph, right? Well, you should not do that with the speed time graph. But I have seen people doing that. Oh, we're not there yet. I've seen people doing that. But it's technically not the right thing. Speed. Speed is a scalar quantity. So it should not have any negative values. So this whole thing is just no. My graph could look however crazy it wants. Of course, you'll never get a graph looking like that. That's just weird. But yes, it doesn't matter. Does not matter how crazy that graph looks. it would never go below this x-axis because speed is a scalar quantity. There's no negative values. Do you understand that? Miss me to understand that after this, please. Do you understand that? Nice. Okay, so that was Micaiah, Troy, Catania, other person. Easy.
I understand, Miss.
Nice. How much time do we have? We have 3 minutes. That's cool. Let me just start the next one time. Okay, this is where calculus comes in. Yay. Calculus is fun. When I say calculus, I mean differentiation integration, right? Calculus can be used to solve kinematics, including displacement, velocity, and acceleration. So if I want to go from displacement, which is usually denoted by S, sometimes you might see X, doesn't matter, right? Once they tell you, okay, this is displacement, that's the symbol you use. If they did not give you a symbol, well, you could use S, you can use X, doesn't matter. So displacement, if I want to go from displacement to velocity, I can actually differentiate. So what does that look like? If I have S, which is displacement, right? If I have S, displacement, and I want to find velocity, well, velocity is actually ds on dt, which makes sense, right? Because if ds on dt is the rate of change of displacement, that's my definition of velocity. Velocity is the rate of change of displacement. So it makes sense that v is ds on dt. Similarly, if I want to find acceleration and they gave me velocity, that's dv on dt. The definition of acceleration is the rate of change of velocity. When we are doing rates, we said whenever I see the word rate, it's on time. It's with respect to time. So dt. So it's always on dt. Remember when we were doing the rates question. And then the only thing you have to find out was what quantity has to come here. In this case, it's velocity. dv on dt, rate of change of velocity. That's acceleration. That's my definition of acceleration. That's why it's important for you to know the definitions, huh? But then you can also use integration. So from displacement to velocity, then velocity to acceleration, you differentiate. But if I want to go from acceleration to velocity, and then velocity to displacement, what would I do? Integrate. Why would I integrate? Remember, integration is an anti-differentiation process. What does that mean? It's the reverse or it's the opposite of differentiation. So if I have this, okay, A is dv on dt, and I want to find v, I would actually just do the opposite of differentiation. I hope you're following that. So if I want to find, let's say, hold on. If I want to find velocity, v is actually the integral of a, and it's dt with respect to time. Let's just say you were given limits, so it's definite, b and a. To do, so let me just say that again. For velocity to acceleration, you differentiate. But what if I want acceleration to velocity? Then notice how this arrow goes. This one is going up, but then this one is coming down. These arrows are the reverse of each other. Up is differentiation, and we know that the reverse or the opposite of differentiation is integration. And that's why we say, if I differentiate velocity to get acceleration, then I would have to integrate acceleration if I want velocity. Differentiation, integration, they're opposites of each other. Do you understand that?
Yes, miss.
Okay, well, I'm gonna end soon though, somewhat. Oh, you said you want to leave it. Okay, let me leave it then. Let me leave it. Okay, let me not do that to you.